In this video, we're going to talk about how string comp works. And later, we're going to talk about capitalization of string. And then later, we're going to talk about swapping pointers. So all those things are useful for sorting in the next video. So please watch this video carefully. So let's think about how string comp works. So one good way to see how a function works is basically writing some simple toy program like this. So I wrote a toy program like this. As we talked about how string comp works, okay, so if A and B are the same, then it will return 0. And if A and B has this, if A is greater than B, that means in a sense is later in the dictionary order. Here, dictionary order is, strictly speaking, is ASCII code order, okay? And then if A is earlier than B, then that should be returning negative. So to actually check how it works, this is the simple program. Printf basically says enter two strings, and using scanf, get the two strings. And I'm going to just printf like string comp s, which is A, and %s, which is B, is the output of string comp. Okay. So if you do that, okay, cat, obviously that's 0, and cats, which should be earlier. Cat should be earlier in the ASCII code order. So that's negative because it's earlier. Cat's cap, which is earlier. Cap is earlier. That means cat is later. So that means it should be returning from positive. The 4 is basically the difference, ASCII code difference between letter T and P. What about cat? If you look at the ASCII code, capital letter C is earlier in lowercase letter c. So that's what? Negative. Okay, so that's how string comp works. And you know, this is kind of useful because we're going to compare the two strings. Okay, and obviously comparing the two strings must be used string comp. Okay, and also now let's talk about how to do capitalization. So let me just write some simple program cap.c. Okay, so this program is basically really simple. I'm going to take one string, and I'm going to just capitalize and print it. Okay, so main function is printf, enter a string, and then I'm going to have create a string that will receive from the terminal the actual string, and then I'm going to print out capitalized, pedalized string A. Of course, in between, you have to call some function. Let's say cap. Cap will be basically the function that will capitalize to modify the string contents of A, so that it could be after the function, it should be capitalized. So the idea is basically whatever the string S will be, just visit each letter one by one. So the indexing should be starting 0 up to the length of S. Okay, so what do? If SI is lowercase, then you capitalize it. So that means if SI is what? In terms of ASCII code is at least A, the ASCII code S is at most Z. If both conditions are met, that means SI is somewhere between A and Z. That's lowercase letter. If that's the case, you capitalize it. How do you capitalize it? You compute this value, SI minus A. This is basically telling you how far away from the lowercase letter A, right? And if you add back, this becomes how far away SI will be from the capital letter A, and that's capitalization, and that's it. Okay. So let's say make cap. Okay. Cap works. Let's see. Enter a string. Cap. That's working. Cat. Working. XX, YY, ZZZ. It's all working. Okay. 1, 2, 3, 1, 2, 3. This is working fine. Okay. So now let's move on to swapping the pointers. Okay. So let's think about this. Make swap P. Swapping the pointers. So let's say I would say P swap. Not make, but VI. Okay. Okay. So I'm gonna basically create two integer arrays. Okay, so I'm going to use calloc. So integer point PA. A is calloc, let's say 3. Okay, and each of the element has size int, and int B is calloc. Let's say 3, the same size. Okay. Okay. So now what is, yeah, I'll just do this. Then I'll just initialize A1 is 0, A2 is 1, A3 is 2, and B, oh, indexing starts with 0. So don't make mistakes like me. Okay, B0 is like 100, B1 is 200, and B2 is 300. Okay, so if you have a print function, okay, print function like this. Okay, so I'm going to write the print function. So print function is basically what? Okay, that's 0.a, 0.end. Given this, what do? You print f percent this, and then for integer I and 0, you scan the array. Okay, basically print a sub I, because this is an integer. Print this, and then at the end of the day, print your new line. Okay, so that's how you write how you print the array. Okay, and also I want to print out the pointer value itself. So %b pointer address of a value of a itself is this. It's a pointer type. So %p is basically used for printing that pointer. Value of b is this. Okay. So here I'm going to swap it. Swap means what? Instead of just calling a function, I'll just like swap it. So how do you swap? You have to have a backup value to store the A, so that now A can be safely changed to B, and then the actual B is the backup value A. Okay, and now let's do that. Okay, so I want to just see how things are going on. So let's look just again. So I create, oh yeah, I forgot to free it's a good practice to free what you callocked. Okay. So here I created two arrays, or like an A and B is the pointers. Okay. And I print out the contents of the array A or contents of B. And then I actually, because A is actually pointer to on first element of the array, I want to print out the address, where the address is. And here I swapped the pointer values. Okay. And then let's think about how things are working. So there are so many problems. Where is this print %s? Yeah, I didn't give string. And then calloc, I forgot include standard library. There you go. Okay, p swap. Okay, so if you see, okay, A's value 0, 1, 2, and B's value is 100, 200, 300. Okay, and no, recall that A's address is ending with 60. Okay, so in somehow in address 60, there's like 0, 1, 2 array, and it tells you in address ending with 80, there's an array with the three elements 100, 200, 300. Okay, and I swapped it. So what does that mean? I didn't change the value of A, but I just changed where the arrow goes. So before, the pointer A pointed to 60. Now, because I swapped the actual value of the pointers only, the pointer is changing to 80. That means it points to other location, which is the location where 100, 200, 300 is. Okay, and then B is basically changed to where the original A was pointing to, because I just swap the addresses. Okay, so in this way, in a sense, swapping the pointers is basically an effective way of changing somehow like where it points to. So you don't need to actually change the array contents, but just swapping the pointers actually makes you to swap, in a sense, virtually the array contents, but not actually. And that kind of notion is useful in sorting the 2D arrays, right? So now 2D array means what? Array of arrays, right? And then each array is actually a pointer. And then you swap the pointer. That means what? You swap where it points to. And that way, without actually modifying the contents, you can effectively swap the arrays. Okay, that will be used in the next video.